The topic of this video is from Unit 3C on asking probability questions with and without replacement. Sometimes two events influence each other, and other times they do not. When two events influence each other, that's the case where we're talking about probabilities or finding probabilities without replacement. When we're asking to find probabilities with replacement, that's when the events do not influence one another. Now in the second bullet, this is where we're talking about without replacement. To find the probability of the intersection of two events E and F, you first find the probability of event E and then multiply it by the probability of event F, assuming that E has already occurred. So you have the conditional probability as part of your multiplication here. Now in symbols, the probability of the intersection of those two events E and F will be equal to the probability of E multiplied by the conditional probability of F given E. But with replacement, if E and F are independent, then knowing that E has occurred does not influence the way we compute the probability of F. So all we have to do to find the probability of the intersection of E and F is to multiply the probability of E by the probability of F. So let's look at an example. Now we're going to draw two cards from the standard deck of 52. Now in the first question, we're going to find the probability of drawing two jacks if cards are drawn with replacement. So we are going to multiply two fractions together. We'll have the probability of the first times the probability of the second. Now the probability of drawing a jack on the first card is 4 divided by 52, because there are 4 jacks in the deck. Now if that card, once it's drawn, is put back in the deck, how many jacks are we going to have left? We'll have 4 jacks still and 52 cards total, because that first card was replaced before we drew the second card. So this reduces to 2704 in the denominator and 16 in the numerator. So reducing the common factor, we get 1 divided by 169. So both of these probabilities are the same for the first card and the second card. 4 over 52 times the 4 over 52. Simply because when the second card is drawn, the first card was put back in the deck. So the probability on that second event of drawing a jack on the second card has not been influenced by drawing a jack on the first one. But if the cards are drawn without replacement, the second card that is drawn, the probability of choosing a particular card will be influenced by what was picked on the first card. So what's the probability of drawing a jack on the first card? That's still 4 over 52. But think about this, that the card is not put back in the deck. So you have 1 less card. You only have 51 cards this time. And if you had 4 jacks to begin with, and one of them was drawn on the first one, there's only 3 remaining. So multiplying, we get 12 divided by 2,652, which reduces to a fraction of 1 divided by 221. Okay, in our next example, we're drawing 2 cards from the standard deck of 52. First question is going to be done with replacement, and we want to know the probability of drawing a face card followed by a non-face card. So the probability of drawing a face card followed by a non-face card. So we do have the intersection of two events. The first event is drawing a face card. The second event is drawing a non-face card. So what is the probability of drawing a face card on the first draw? Well, there are 12 face cards out of 52, and we're going to multiply that by the probability of getting a non-face card on the second draw. Now the first card has been put back in the deck since these cards are drawn with replacement, so we still have 52 total, and we have all 40 non-face cards still in the deck. So this is a total of 480 divided by 2704, which reduces to a fraction of 30 divided by 169. Now for the second question, the cards are drawn without replacement. So your probability is going to be equal to a multiplication of two fractions, where the first fraction, well, what's the probability of choosing a face card on the first card? 12 over 52, but we have to remember this time that the cards are drawn without replacement. So the probability of the second card is affected by what was drawn on the first one. Right? We have one less card in the deck because it was not put back in the deck because these are drawn without replacement. Now we had 12 face cards to start with. Assuming that one of those was drawn on the first pick of your cards, how many non-face cards do you still have left? Well, there are still 40 in the deck because a face card was drawn on the first one. So when we multiply, we have 480 divided by 2,652, and reducing that fraction to 40 divided by 221.